Yeah, free response questions do tend to be pretty consistent. So the first one focuses on composition of functions, graphing, evaluating the functions, their transformations, their zeros, and then analyzing the end behavior of those graphs, and then working with inverse functions. So let's take a look at this first example. Here, the first question is a composition of functions. You're taking g of f of x. So if we work with the inner function, which is f of x, given by the table up here, and then the g function is given by the equation. So it says find the value of h of 10. So when we look h of 10, the inside function is f. So if we search for the input of 10, its corresponding output is 12. So really what we're now working with is g of 12 is what we're being asked to evaluate. And if this is our function right here, g of 12 is 5.63 times 1.08 to the power of, and I'll put 12 here, is what I'm evaluating, and that will give me my solution. If I were to do it on Desmos, I could type my function g of x in, and I'm using function notation so I can more easily evaluate it, but 5.63 times 1.08 to the power of x, and I'll leave x in that form. And here I can just say g of 12, and I get my same answer. Okay, the next question asks to look at this table again, since it's referring to function f, and it wants all values for which f of x is equal to -4. So notice there's two repeated values, 6 and 12. So 6 and 12 would be our solutions. Next, it's asking us to, again, now look at the g function and see where it's equal to -16. And so when we look at our graph here, we can just write an equation for that horizontal line at y equals -16, and we can see where those intersect. And if you zoom out here, what you could see is they're never going to intersect. So this is a DNE, does not exist. Looking here now, still staying with the g function, the end behavior as x decreases. As x is decreasing here, again, what we can see with the graph is it's getting closer and closer and closer to 0. So that is our limit. And you might be expected to write the full limit notation here. So the limit as x approaches -infinity of g of x is equal to 0. Next, it's asked, is the f function, so now we're going back up here and referring back to the f function, is it invertible? That means, does it have an inverse? In order for it to have an inverse, it would need to be 1-to-1, and you can see here that two different inputs give the same output, so when you take the inverse of this, -4 could equal 6 or 12, which means that is not a function, therefore it's not invertible, and the reason was just what I explained. F of x has outputs that are not mapped to unique inputs, therefore there can be no inverse. So those would be my answers, and you can see here they are verified.